Section 6, Protective Measures and Ambient EMR Minimization. Based on the discussion in Section 5, it becomes very clear that the people exposed to EMR must adopt some preventive measures to limit their exposure to harmful RF EMR. In many situations, such as those discussed in Section 4, we are exposed to EMR almost daily for prolonged periods of time. While it may not be possible to entirely eliminate such exposure, such as in workplaces, some protective measures could be taken by people to reduce the amount of EMR they absorb and thereby reduce the damage done to their bodies. In this section, we present some techniques which are either based on externally attenuating the EMR before it hits the body, and some techniques based on monitoring and deploying the EMR sources effectively and efficiently so as to minimize the ambient EMR levels. The techniques based on external attenuation have to be practiced on an individual level, while the ambient EMR minimization techniques can be practiced on government and society levels only. I am absolutely for, hey everyone, this is John Harcrane. I am absolutely for being effective and doing things efficiently and to solving the correct problem and not being rooted in the wrong problem. We have a problem on our hands here. It's kind of like smoking on planes when they used to do that in until the 80s or somewhere in the 90s. And people said, this is not good. We can't have this anymore. And so have been born and we have essentially accepted that this is the way things should be. And I am calling horse hockey on that. We have to start understanding that we do not consent to having our immune systems compromised, nor do we consent to the V word that all the doctors are going to be forcing upon all of us so that we can have certain elements put into our body via injection so that we can be a part of this medical construct that wants to make us sicker. Sorry, that's just a little bit of a pet peeve of mine right now, the medical construct, considering what they've done to just about everybody. Part A, protective measures. Number 1, EMR absorbing cloths. As a result of the research in the past decade suggesting the dangers of EMR on the human body, a variety of EMR absorbing clothing solutions began surfacing the market. Such clothing options incorporate surface metallized fiber woven fabric in their apparels. Metals like copper, silver, or aluminum are chemically deposited on ordinary knitting fabrics to obtain surface metallized fiber knitted fabric. Such metals are known to attenuate EMR by scattering incident radiation. While manufacturers do claim a specific EMR absorbing efficacy in decibels over a certain frequency range, it cannot be said for sure whether the attenuating rating claimed by such clothes was obtained through well-designed tests. Such clothes are generally bilayered, where the first layer reflects some of the incident EMR and the second inner layer absorbs the radiation which passed through the first layer. The higher the decibel value, greater is the shielding capability. Most of the materials have a characteristic range of frequencies which they absorb. For example, a product that has an effect of 30 decibel at 1 to 5 gigahertz would mean that the product blocks 99.9% of radiation in the wavelength range of 1 to 5 gigahertz, which includes most of the RF EMR encountered commonly: cell phones, Wi-Fi routers, and Bluetooth devices. Metals are the best solution to reflect EMR. Hence, such clothing generally has metallic strands of metal silk fibers embedded within them, which reflect incident EMR away from the wearer's body. Metal silk fibers are also blended with regular fabric to obtain specially designed electromagnetic shielding fabrics, which are used to make different clothing products such as curtains and blankets. Chemical disposition processes are also used to form a conductive metal plating on top of regular fabric. In any of the above-mentioned varieties of EMR protective clothing, the shielding capability increases with the amount of metal used in the product. Pregnant women, young infants, and children are especially recommended to wear radiation protective clothing due to their higher vulnerability of radiation absorption and damage. Workers who are exposed to abnormal high levels of EMR, such as cell tower repairmen, need specially designed EMR reflective and protective clothing designed specifically for their occupation. Number 2, EMR absorbing reflective paints. Many households are located very close to cell towers, which have multiple antennas operating on them. The wall facing in the direction of the tower is most exposed to RF EMR. It is unprotected, i.e. it does not have any absorptive reflective coating. If it is unprotected, i.e. does not have any absorptive reflective coating, the people living in such homes are more prone to develop EMR-related health issues as discussed in Section 5. One very effective way to prevent high levels of EMR from penetrating the home is to use EMR absorbing reflecting paints, which are specifically designed to absorb, reflect, or scatter EMR in the RF frequency range as it is emitted by the cell towers. It is desired to achieve high levels of attenuation across a wide frequency range. Materials that have numerically equal values of permittivity and permeability and high loss of tangents are most suited to be used in making EMR absorbing paints. The former characteristic guarantees good impedance matching with the air and thus enable incident signals to enter the surface without any reflection. The latter characteristic enables the material to attenuate the EMR rapidly before it enters the home. By using such materials, the reflection is also minimized. So people standing outside the homes are also protected from high power EMR reflected from the walls of the homes. The power radiated from cell towers at certain frequencies may be much higher than others. EMR absorbing paints can address this problem as well because the frequency range at which maximum attenuation is achieved can be set by varying the thickness of paint applied on the wall. Choosing a thickness to match permittivity and permeability can result in considerable increase in the absorption bandwidth both at normal and oblique incident of EMR. For example, there are 2 varieties of paints to absorb EMR. Both their formulation have a polyurethane matrix. Carbon iron powder and polyaniline are the chemicals dispersed in the matrices of 2 formations respectively by mechanical agitation. The attenuation plots of these paints are shown in Figure 12A and B respectively. The paint of Figure 12A achieves attenuation of 8 decibels, 84%, at 10 gigahertz, and the paint of Figure 12B achieves attenuation of 4 decibels, 60%, at 12 gigahertz. Such paints could be used to shield the EMR coming from 5G towers, which are much higher than any RF communication used till date. To ensure the best protection, on-site testing can be done to accurately determine the frequency at which there is a maximum radiation and also the minimum attenuation required to ensure that the residents are protected from any harmful effects. The customers can pass on these specifications to the manufacturer, who can then adjust the chemical composition and also suggest the thickness required according to the customer's needs. This would ensure maximum protection at minimum. This is part 3, aerogel. Aerogels are a high class of high-performance EM radiation-absorbing materials designed by fitting several nanosheets of graphene into 3-dimensional structures. Their excellent absorption characteristics is due to their high surface area and dielectric loss. The reflection loss, RL, of the material is a characteristic of the input impedance. Okay, take a look at this, please. Okay, this is above my pay grade. I used to do chemistry, and I was really good at algebra. I'm not diving into that one, okay, guys? Dum. In the above equations, Z sub 0 is the impedance of the E sub R is the complex permittivity. Micro sub R, I think that's what it is the relative complex permittivity. F is the frequency, D is the material thickness, and C is the light of speed. All right, cool. According to fundamental mechanism of electromagnetic absorption, the most effective absorption would take place when the impedance matching conditions between the material and the free space is achieved. Plots of reflection loss, RL, versus frequencies such as in Figure 13 are prepared for various thickness of the aerogel material. Such plots may be used to choose the best material for an application, considering into account the most prominent frequency of radiation and the thickness of absorbing material permissible. The frequency at which highest RL occurs varies with the thickness of the aerogel, as can be seen in Figure 13. As the thickness of the aerogel pellet is varied, new phase matching conditions have to be established in order to maintain the RL. Good luck with this one. Wang. Okay, this is from Brother Wang. Have prepared ultralight and mechanically strong 3D composite graphene aerogels with the use of waste cigarette filters. Awesome. Their composite aerogel showed a minimum RL of minus 30.53 decibels with a bandwidth of 4.1 gigahertz. One coating with polypyrrole, a conducting material, the new composite showed minimum RL of minus 45.12 decibels. Similarly, XE, I can't pronounce Chinese. Similarly, this dude prepared a self-assembled ultralight 3D papyrole 3D PPY aerogel, a composite which can reach an effective electromagnetic bandwidth of 6.2 gigahertz with a minimum RL of minus 25 decibels. Wu is the way, Tang is the slang bee. Wu prepared a sponge-like, self-assembled ultralight aerogel which showed a minimum RL of minus 44.44 decibels with a bandwidth of 6.76 gigahertz. The above-mentioned aerogels and their absorption characteristics are summarized in Table 6. Wonderful. Look at this. Sorry for ab-libbing, guys. I'm just trying to make a little bit of fun. I mean, come on, Wu-Tang. Wu-Tang, everybody. Part B, ambient EMR minimization. Number 1, with ever-growing consumer demands for telecommunication services and the deployment of 5G technology soon to come, many new base stations will have to be deployed over the already existing 2G, 3G, and 4G network. Therefore, it becomes very important to achieve optimal deployment of cellular base stations or wireless access points in order to minimize radiation levels. Compared to most optimization solutions in research, a bunch of different numbers, which have considered deployment cost, coverage level, and base station capacity in the objective function, Sesendo Sans have considered an additional criterion, electromagnetic pollution. They have proposed a solution called Grouping Coral Reefs Optimization, GCRO, and demonstrated its effectiveness when applied to a mobile network deployment problem, MNDP. Daruk, all these people who've done this research, Daruk, another one, have presented a tool which achieves different levels of optimization for power consumption and human exposure in LTE networks. Pleats have developed a GenTIC optimization algorithm for wireless local area networks, WLANs, which optimizes the exposure index EI, taking into account all sources of exposure such as uplink, downlink, and the uplink of others. Realistic duty cycles while simultaneously ensuring quality of service to all users. Another person proposed important guidelines to be followed during deployment of 5G base stations in order to achieve EMR-aware 5G networks. These guidelines include modeling of 5G radio technologies, which helps to select the proper configuration of the installed equipment for each considered site, modeling of the generated EMR levels over the territory, which allows for a fine-grained antenna site characterization based on the knowledge of the radiation pattern and the emitted power of each antenna in the site, integration of the current and future EMF limits, modeling of the set of candidate sites based on idealized distributions and operator-based constraints, modeling of 5G traffic demands, and QoS, quality of service, based on spatial and temporal fluctuations that can characterize the radiated power demand, and modeling of 5G network topologies. 2. Electromagnetic pollution monitoring using wireless sensor networks. With new base stations being installed on a daily basis, monitoring EMR pollution on a real-time basis becomes essential to detect and locate potentially dangerous EMR levels and notify corresponding authorities to ensure safety of nearby people. In this regard, New, another person, proposed an EMR pollution monitoring system using a wireless sensor network, WSN. based framework. Their system used a genetic algorithm on EMR data acquired from WSN nodes to detect and report any EMR limit violations. The WSN nodes are deployed uniformly over an area and are equipped with sensors to detect EMR in the frequencies which are most prevalent. This is Section 7, Proactive Preventive Techniques. Certain steps can be taken by an individual to avoid EMR exposure. That's electromagnetic radiation. Spreading awareness about dangers and health hazards of EMR in schools, hospitals, and other areas having sensitive population, such as pregnant women, small children, and old people, and giving them simple suggestions based on their surroundings can help a lot of citizens avoid EMR-related health issues without spending resources on integrating and deploying EMR attenuating technology. We have listed few such proactive and common sense measures to minimize unnecessary and needless EMR exposures, keeping in mind various environments and operating conditions. Number 1, in residential places such as homes, at study table, and other places where people sit for long periods to use internet, we can have Ethernet cable to avoid getting exposure to 2.4 gigahertz Wi-Fi signal. Many switches to control the power to Wi-Fi router can be installed throughout the house to readily switch off the Wi-Fi radiation when not in use. The windows can be covered with transparent EMR absorbing reflecting thin film, and outer walls can be painted with EMR absorbing paints. Use of landlines for long talks should be preferred over mobile phones and cordless phones. Rooms of children below the age of 12 should be particularly safeguarded from EMR, as they are more prone to EMR-related health issues. Number 2, in hospitals and medical institutions, it is especially important to implement guidelines regarding EMR safety, as hospitals cater to very sensitive populations such as pregnant women, newborn babies, and unhealthy people. Hospitals should not adopt full Wi-Fi coverage technology. Preferably, they should give Ethernet ports to all doctors and hospital wards. Government should lay guidelines to not allow deployment of base station or cell tower in near vicinity of hospitals. Units for sensitive populations like ICU, CCU, NICU, and operation theaters should avoid all sorts of devices which use wireless communication, such as wireless incubators and remotely operated instruments. Only those sources of EMR should be used which are meant for medical purposes. Pregnant women should be educated to avoid prolonged use of mobile devices, laptops, and other wireless devices. 3, in educational institutions, there is a trend to shift to modern technology like wireless projectors in smart classrooms, campus-wide Wi-Fi access, use of digital notebooks, etc. As we have mentioned in Section 5, children are very sensitive to EMR, and health issues like autism and impaired mental development are becoming very common among young population. Schools where children spend almost 8 to 10 hours need to minimize the ambient level of EMR inside the classroom by using EMR absorbing paints and window films. School authorities should give special rules and guidelines for population density zones such as classrooms and school buses, which get rarely high EMR levels due to everyone using wireless devices simultaneously. If all classrooms cannot be made to comply with EMR safety standards, schools should construct special classrooms to maintain no wireless condition and allow students to opt for it who believe their academic, social, or behavioral progress is being hindered by EMR-related health issues. Isn't that amazing, that last line? We're being hindered regardless, across the board. Section 8 of electromagnetic radiation due to cellular, Wi-Fi, and Bluetooth technologies. How safe are we? This is the discussion section. Currently, employed public exposure limits do not provide sufficient protection to people in terms of long-term and short-term exposure. The exposure limits specified by ICNIRP take into account only the thermal effects and not the non-thermal biological effects in determining their limits. The ICNIRP safety exposure limits for general public for wireless technologies discussed in this paper are between 4 million microwatts per square meter to 10 million microwatts per square meter, which is several orders of magnitude higher than the limits prescribed by the Building Biology AMA and the Bioinitiative standards. While exposure levels within the limits prescribed by ICNIRP only guarantee safety from the thermal effects of EMR exposure, there are numerous scientific studies suggesting that even non-thermal effects pose a significant threat. These non-thermal effects are observed at several orders of magnitude of radiation lower than those of thermal effects. Along with the thermal and non-thermal effects, several other factors such as frequency, duration of exposure, pulse shaping, power level also attribute to health risks of EMR, electromagnetic radiation. It has already been several years since the wireless technologies have been deployed, meaning that the public has already been exposed to a lot of harmful EMR without their knowledge. It may be anticipated that this section of the population will suffer from many health hazards discussed in Section 5. If corrections are not made now, especially when the number of wireless devices are growing exponentially, which leads to an exponential increase in public EMR exposure, the current and future public will be at even greater risks of both known and unknown health hazards. In particular, women, children, and fetus are hypersensitive to EMR, and special care must be taken to protect these groups from both short and long-term exposure. Smartphones, laptops, Wi-Fi routers, Wi-Fi hotspots, and Bluetooth devices such as speakers, earphones, and smartwatches are the most common sources of exposure today. These devices are used extensively in very close proximity. Based on the discussion in Section 4, it is clear that usage of mobile phones for calling or data streaming, using laptops and smartphones or Wi-Fi networks, using 4G wireless hotspots are especially dangerous. Exposure to radiation from one or two devices, such as smartwatch on the wrist and a connected smartphone, may result in high radiation levels only near the hand and pocket region. A cumulative and simultaneous exposure to several sources of EMR, such as a laptop, smartphone, Wi-Fi router, Bluetooth earphone, smartwatch, and speaker, lead to dangerous levels of EMR all throughout the body and must be avoided. While it may take very long for exposure levels of these devices to be corrected, the users can take steps to minimize the risk of using these devices. A summary of recommendations regarding usage of these devices is given in Table 7. Dum dum dum. This is for cell phones, smartphones, and cellular networks. Recommendations. Number 1, network. For internet connectivity, prefer Wi-Fi. If not available, prefer to use 4G networks for both calling and browsing data streaming. 2, calling. Use wired headphones and keep the phone at least 1 meter away while calling. 3, browsing and video streaming. Keep the device on a table platform at least 50 centimeters away. Wi-Fi devices. 1, prefer smartphones over laptops for casual work such as emails and browsing. Keep smartphone, laptop on a table and operate from arm's distance, 50 centimeters. Avoid keeping smartphone in the pocket while it is connected to a Wi-Fi router. Avoid keeping laptop on the lap while it is connected to a Wi-Fi router. Wireless ad hoc transfer. Stay at least 1 meter away from both sender and receiver. 4G wireless hotspot. Stay at least 2 meters away from the device while it is active. Bluetooth devices. 1, speakers. Keep speakers at least 25 centimeters away and connected speakers at least 50 centimeters away. 2, smartwatch. Avoid unless absolutely necessary. Earphones. Avoid unless absolutely necessary. There are wired solutions in each of these use cases which can be adopted to greatly minimize EMR exposure. Use hands-free earphones to make phone calls, using LAN cables instead of Wi-Fi, wired earphones, switching off Wi-Fi routers when not in use, maintaining a good distance from wireless devices are some of the measures to minimize exposure. A twofold approach can be followed to minimize harm from EMR pollution. Firstly, measures can be taken to protect people from the already existing high levels of EMR. Second, proactive prevention techniques can be adopted in environments such as households, schools, and hospitals to greatly minimize EMR exposure. These have been explained in detail in Section 6 and 7 of this paper. Both individuals and governments must be aware of the fact that the current population has already been exposed to dangerous levels of radiation and the resulting adverse health effects may surface in people at any time. In this regard, proper planning and execution, both on governmental and individual levels, is required to properly handle a breakout of EMR-related health issues in large number of people in all areas of the world. Specifically, it must be noted that the radiation in 5G networks is suspected to increase by several folds. It will not only affect regional near cell towers and 5G devices, but all indoor and outdoor environments in the region of coverage. Thus, almost all people in the area of coverage of 5G networks may be exposed to dangerous levels of EMR. Without thorough research and well-designed safety measures in place, widespread deployment of 5G networks could prove to be dangerous. This is John Hart Crane reporting from Sanibel Island, Florida. It is April 2nd, 2020, and we're talking about what radiation does to our immune system. This is section 9, conclusion. People should be made aware that the EMR, electromagnetic radiation, from using day-to-day cellular, Wi-Fi, and Bluetooth devices are harmful to human health. The levels of radiation observed in most cases, such as phone calls, internet browsing on laptops and smartphones, using wireless routers and hotspots, Bluetooth smartwatches and smartphones, are unsafe when compared with radiation limits determined by medical bodies. According to the current medical literature, various adverse health effects from exposure to radio frequencies, electromagnetic radiation, have been well documented. For now, wireless technologies must be avoided as much as possible. New and innovative wired solutions which provide the same level of user-friendliness should be encouraged. Intervention of government and medical bodies with the main purpose of protecting human health is of utmost necessity to ensure good economic deployment without compromising the health of the population. Countries must adopt the guidelines suggested by medical bodies which take into account both thermal and non-thermal effects of EMR. At present, all individuals must take preventive and protective measures to protect themselves from harmful EMR exposure. It is today, and we are in lockdown, and they are sitting here pulsing every single person, talking about how people aren't abiding by social distancing. They're making you sicker. This research was made possible by NPRP 10-1205-1600-112 grant from the Qatar National Research Fund. God bless you guys. A member of the Qatar Foundation. The statements made herein are solely the responsibility of the authors. Who are they? Bless you guys. Nareen. He's in India. Honorable Javi. Elihans. Abu Nabi. Anab Hav and Hans in India, bless you. Vinay Kamola, bless you. Mohsen Ghazani, bless you.